Okay.
All right, your timer starts now.
Good afternoon, everyone. We are thrilled to introduce Harvest Shield, a groundbreaking innovation in agriculture brought to you by Team 6. Our mission is simple yet powerful to revolutionize farming by empowering farmers to spot pests and diseases early, ensuring healthier crops and more sustainable practices. With a passionate and diverse team, we've crafted Harvest Shield, a game changer for agriculture. From left to right, we have Veronica Delight, Nicholas Delight, Mahitha, and Maria. Let's dive into the challenges we aim to solve as we like to say from the field to the future. Now shifting focus to the problem analysis with my colleague Mahitha.
Thank you, Veronica. Did you all know that the US loses around $120 billion worth of crops each year due to pest and disease damage? That's about $370 per person. Climate change is making pest problems worse, and even genetically modified crops are struggling to keep up, as seen in these articles. Worldwide, up to 40% of crops are lost to pests and diseases, costing a staggering $220 billion annually. Clearly, there's a huge need for a better solution.
These losses underscore the urgency for an effective solution. The problem often becomes missing early science and leading to bigger problems down the lane. That's where Harvest Shield comes in.
Harvest Shield is here to change the game by using the latest tech. We leverage computer vision and a remediation model to instantly detect issues and recommend efficient treatment, while our GPS integration pinpoints exact problem areas. This means fewer harmful chemicals and healthier crops benefiting farms of all sizes. Now let's discuss our market finding and research.
To put what Delight said into perspective, large farms typically lose 5 to 15% of their crops, while small farms can see losses of 25 to 40%. Harvest Shield bridges the gap, making advanced technology accessible to everyone. Our interviews with local farmers led to surprising results. Almost all of them relied on integrated pest management from university and faced significant financial losses, sometimes avoiding certain crops or dealing with pests manually. Shockingly, most farmers did not use technology to identify pests and were unaware of existing apps. Only one used Google Lens.
To add to that, our survey respondents emphasized the critical role of managing plant diseases and pests for food security and environmental health. They estimated US annual crop losses due to pests and diseases to be around 6 to 20 billion US dollars, which is much lower than the figure we presented earlier.
Up next, we'll cover our innovation and unique features. Here's how Harvest Shield works. Camera identification accurately detects pests and diseases. Remediation and prevention provides practical advice and solutions. Dataset development provides scraped data from IPM URLs and Wikipedia with up to 160K rows of functional text information. And our user-friendly interface adds ease of access and geographical integration.
We can't hear it.
Okay, hold on. Let me reshare this. Let's dive into our deep learning model specifically tailored to identify crops. We begin by importing libraries and pre-processing our data with techniques like augmentation. Here's a visualization of our training. We utilize a custom configuration of the Visual Geometry Group 16, or VGG16, a renowned architecture in deep learning, ensuring our model accurately captures complex features from plant images. Finally, let's observe the model in action. We'll see its predictions on a set of images and even test it with a new image sourced from the internet, demonstrating its practical applicability and reliability in real-world scenarios. And 26 represented spinach.
This model focuses on detecting various pests in crops. The model leverages data augmentation to increase diversity of the data. It utilizes deep learning with MobileNet as the backbone of the model, which is a simple and efficient, but not extremely computationally intensive, convolutional neural network often used for mobile vision applications, which is perfect for our intended platform. After training and validation, the model is evaluated on a separate test set, and the results show promising accuracy. As you can see here, the model accurately predicts that this image contains aphids.
I began by web scraping data from integrated pest management, gathering over 160,000 rows of usable information on mediation solutions. This extensive data set was used to fine-tune a pre-trained tiny bird transformer model. The model classifies and predicts the most effective pest control solutions based on input parameters like crop type and specific pest, with an accuracy of up to 0.93 after 20 epochs. With the dynamic prompt system integrated, users can input crop and pest details to receive precise recommendations like the prompt shows.
Now let's explore the app's interface. Hi, this is a very quick demo of what the app's interface would look like and include. You start by selecting your app feature preferences and then fill in your details to create your account. Once your account is set up, you can also specify your location preference, which is a very important aspect of our product. You also select a subscription plan based on your preferences. One important feature of our app is the search and community forum where you can search for your crop-related concerns. We also have a filter available to modify your search. Another aspect is the inbuilt AI-powered chatbot with camera features that you can use for personalized assistance. Here in the demo, I'm asking the Harvest bot how to get rid of Fusarium. We also have a plant inventory available within the app. Here you can keep a registry of your plants and crops. The app will keep a track of the crop growth, requirements, and notify you with updates, including those for harvest, weather alerts, or unusual trends. Thank you. Our app focuses on simplicity and efficiency, making it easy for farmers to navigate and use every day.
Let's examine our project's competitive landscape. Harvest Shield stands out from competitors like Plantex, Prosper, and Tyrannus by using local data, comprehensive solutions, and being incredibly user-friendly.
We provide an integrated, accessible approach, filling the gaps left by other tools and competitors. Our competitors lack comprehensive solutions and user-friendly interfaces, and also sometimes the integration of local data. Harvest Shield is the ultimate ally for farmers, aiming for better productivity and sustainability.
Now let's focus on the ethical considerations. Respect for well-being, autonomy, and fairness are at the core of Harvest Shield. Here's how we address these principles for farmers, the community, the environment, and future generations. Now I'll let my colleague Nicholas delve into the legal and ethical considerations behind it.
Thank you, Veronica. At Harvest Shield, we adhere to data privacy laws like GDPR, CCPA, and PDPA, ensuring that all collected data is handled securely and transparently. Farmers' personal and agricultural data is protected.
To add on to Nicholas, our ethical AI practices ensure that our models are fair and transparent, following guidelines from the EU and the USA. Looking ahead, we plan to enhance our pest and disease tracking features with possible IoT sensor integration and expert recommendations.
All right, thank you, team. Your time is up. We will now have 3 minutes of Q&A. Good job. Judges, if we can start asking questions, that would be great.
I have a question. How do you know what is there any remediation tactics for what happens if it recommends something that's incorrect for a remediation tactic?
So I would defer to Veronica to speak on this, but mainly our remediation tactics, they're kind of recommendations and they have sort of a usability case. So I'll let Veronica speak on that.
Yeah, so when I was basically creating the Transformer Tiny Bear model, I used a lot of data. Obviously, we have issues since the IPM data site is not, it doesn't have balanced input data, but I was able to filter out a lot of it based on like specific results and ratings. So for example, when you actually ask for the solution, it gives you this solution is like 80 to 100% like approved and so on based on their data. I feel like when it comes to realizing like accounting for the problem, it becomes an issue because the data can overgeneralize, as you said. But for our model, for the purposes that we did, since we obtained the necessary results, we didn't like really go too much into detail. Obviously, the model is more convoluted, and even just the data scraping was very heavy. So I would say that those are future solutions that we have to account for because specific cases sometimes could mess up the model, depending on like how the data is spread out.
Cool, thanks.
We have time for one more question.
Sorry, I was muted. On the identification of diseases, how did you train that? What kind of data did you use? And were you able to actually validate that it was accurate?
So in the demo, we actually did a project run where it did an image and it correctly identified it, but I'll defer to the creator of that model if they'd like to speak more on it.
Yeah, so it was able to detect correctly that there was an aphid in that specific image. So we basically used a separate training and testing data set, and then we were able to validate it. And yeah.
Awesome. Thank you, team. All right, if you could stop